Classic arcade and console gaming continues today on Mikey's Lab. Hi, and welcome back to the lab. If this is your first time joining us, go ahead and click the subscribe button down below to stay caught up on DIY, making, science, technology, and engineering news. Today we are continuing the retro gaming end table project with the Ikea table. In the previous video we completed the physical build, the modifications to the table, and the modifications to the monitor, and got the gaming controls embedded into the table itself. Today we're going to take a more detailed look at the individual controls that are part of this project. We're going to show you how to wire them up and how they talk to each other. We're going to look at the power system for the table. And then in the following videos, we're going to kind of split into two different sections for a couple of videos. One regarding doing this with a Raspberry Pi, and the other regarding doing this with an iMac 6. And then we're going to come back together once again and do a few videos that usually aren't part of these retro gaming tutorials, but is a huge gap in the knowledge, I feel. And that's, we're going to look at each of the individual emulators that make up the RetroPie project. We're going to find the best settings for them. We're going to verify that the ROMs that are out there work. So by the time we are done this series, you will have a completely working solution to the problem. So let's dive down to the bench for a second, and let's take a look at the individual components that make up the arcade controls we are using on the table. Alright, so here we are at the bench, and the first thing we're going to take a look at up close is the actual arcade controls. What you'll find is that every control is very similar. I know I've talked about using a HAP style control in the past. However, this particular build and this particular purpose for this wanted lighted buttons. Lighted buttons are not available in HAP, so we went with a different style, but I wanted to show them to you anyway. So the unique thing about these buttons, they have the standard collar like every arcade button does. All right, we'll take the collar off just temporarily here. You can see, if I bring this a little closer here, there are 4 pins. 2 of the pins are connected to a micro switch. 2 of the pins go into the upper part of the button. The 2 pins that go into the upper part of the button are for illumination of these buttons, so that when they're pressed they will light up. The other 2 are the normally open contacts of the micro switch for this button. If we take a look at the wiring harness, the encoder we're using is a 3-wired encoder designed for illuminated buttons. So you have the yellow light, which is your positive line to illuminate the button. You have a shared ground line, which as you can see comes back out, loops back in, and connects to both the button and the LED itself. And then you have the signal line for the button itself. So the encoder detects when the button goes to ground and will do whatever action it's been programmed to, usually emulating either a gamepad button press or a keyboard button press. In our particular case, it emulates a gamepad. Okay, this is a slightly different model than the encoder that we're using. This is the ones that I normally use. These ones, as you can see, have 2 contacts for each button. Right, because again, I normally don't do the illuminated button style of buttons, so they come with a wiring harness very much like this, which is just, you know, your 2 contacts for the normally open micro switches. So what this will again do is it will emulate a USB joystick, and you can, in the software, define which button on the joystick references which button from the classic arcade systems that we're working with. If you're using libretro, whatever you set up inside of Emulation Station, which will become much more clear when we start talking about the software for this project, will automatically be transferred through there. And if you're using any other emulator, such as MAME for All or Dolphin, you're going to need to set up the key mapping for that particular emulator. We'll go through that all when we start looking at the software itself, especially customizing for each emulator. Alright, so now we have the joystick. As you can see, I've taken off the faceplate of the joystick. If we take a look at the bottom, we see that all a joystick really is 4 buttons. Right? So one of the things to remember when wiring this up is that if I press up on the joystick, right, so the joystick is going that way, it's this button down here that activates. So when you're wiring this into this particular harness, right, wherever it says up, which is AU here, so player A, U for up, right, you want to wire the bottom micro switch. The same thing is true for left and right, where they are inverted as well. Now these particular buttons, if I can find a screwdriver, have a neat feature to them. And again, I don't normally use these ones. All right, so you can see on the side of here, if I bring this a little closer, that there are 2 indents, okay? And there are little clips inside here. So if I go ahead and just push that clip in on that side and push that clip in on this side, and it runs away. You see that the button comes into a couple pieces here. Inside we can see that we have the micro switch, and we can see that right down there there's an LED, and right down there there's an LED, and then there's the resistor required to make the LEDs work. But one of the things that I like about these buttons, and again, these are not my usual the usual buttons that I use. If you take a look at the top itself, it's got the plunger that depresses the micro switch like a standard button, but we can pull that out. In here we can take either vellum, transparency, something along those lines, and we can print text, we can print symbols, and then reassemble the button. And then when it illuminates, those particular symbols will show through the button itself. And then again, you just take the enclosure of the button. There we go. So it does only go together one way, and we have the button back, and it has that nice, I don't know if you can hear this, but this is like my favorite sound in the world with arcade buttons. They must have that nice clicky sound to them. And of course, don't lose this. This is the thing that you put over top of the hole in the table so that it doesn't look as big as it is, and it makes everything look nice and neat. So if you refer back to the construction video, the first video that I did on this, I show you how to put these into the actual table. We're going to step away for 1 second, and we're going to come back and we're going to look at the power system that I have designed for this table, because as I've mentioned in many videos, I had the goal that there can only be one power line going to the table for this to work. I don't want wires everywhere. I want this to be a very neat, very concise build. So I'm going to clear off the bench. We'll come back in a second, and I will show you at the bench here the power system that I have designed and built for this particular table. All right, so what we have here is essentially the power system that will power everything that is inside of the table. We have our 3 wires here that connect up to mains voltage in, okay? We have basically what's the inside of a power transformer normally is. It takes in the 110 volts AC, it spits out 12 volts at 5 amp. The 5 amp is important. There's some power hungry components going on here. So what we do then is it comes into a voltage regulator. Okay, so we have one lead coming off here for 12 volts output. This will be used for under table lighting in this particular project. And then we have another lead here, which is 5.2 volts, which is the industry standard for USB. The other, this power lead here that comes here, comes to a standard PC power jack. This is to power the monitor with the 110 volts. So when we go to install this into the table, what I'll be doing is I will be feeding a bare line that has, again, your white, your black, and your green, so your hot, your neutral, and your ground, into the table, providing some strain relief to it, attaching these leads to those 3 that are coming in, soldering these, heat shrinking these, and then electrical taping these. I've said it before, I can't say it enough. This is household mains current. It's not the most dangerous current in the world, but it is enough to kill you. So you need to have respect for this level of power. I have learned the hard way many times and have learned to very much respect this. So following up on the power supply, I'm just going to leave this here because it does come into play. The next thing that I have done is I've stripped down a USB hub, which is this thing right here. This USB hub used to have a barrel jack here to allow a 5-volt feed into it for extra current. Instead now it has a JST connector, very much like the 5-volt feed from our power rig does. So what's going to happen is this will plug directly into our power rig, feeding this with 5 volts. This 5 volts here will then be power the Pi through one of these. If we're using the IMX6, there'll actually be a splitter connector here, one to go to the IMX6, one to come to this hub. So again, this will act as a hub and a power supply to the Raspberry Pi. From there, we need to power our HDMI to VGA adapter. This does require external power or it does not work properly, so in order to power that, we're just gonna plug that into one of the ports onto here. The next piece of electronics that is processor independent. Again, that's what I'm focusing on now, is all the electronics that go into the table that are processor independent. So they'll be the same whether we're using a Raspberry Pi, whether we're using an IMX6 processor. It might be slightly different if you're using a full PC, because I don't know how you'd fit that in here at this point, but regardless of the microprocessor that you're using or the ARM processor that you're using, these components will be the same. The next piece that I recommend is a laptop hard drive with an adapter cable. Okay, now with this particular laptop hard drive, as with most, if you take a look at the power requirements that are written on them, this thing requires 5 volts DC at 0.55 amp. So just a little more than your standard USB port will supply. So the cable on the other end has 2 ports. Okay, the way that these work is that this one, the first one in the line here, does data and power. This one does power alone. So for our power subsystem, we're only going to plug this one into the power subsystem. This one will be connected to whichever processor we're using, whether it's the IMX6 or the Raspberry Pi. Right, so with all of these powering up this way, it should be nice and relatively stable, and we should be able to fit it all inside the table itself, giving us the requirement that I stated before of only one power cable coming into the table. Now, I realize that there might be a secondary cable if you want to run Ethernet to whatever controller you're using. My recommendation actually is to go online and buy one of the cheap Wi-Fi adapters. I don't have one for this project at this point, but that will probably be an addition that's coming very quickly. So what I'm going to do at this point is we are going to come back up from the bench. We're going to install the power supply into the table. We're going to install the USB hub into the table, the hard drive into the table, and then we'll wrap this particular video up. And then the next video will be us doing the connections with the Raspberry Pi. All right, so we've stepped outside of the lab, as you can see. We've come up from the bench. We're out here. We're going to do the common components and common electronics install into the table itself. As with the previous video, there's just not enough room in my lab to do it there. I did do one other thing, and that's I've taken the transformer and I've taken the voltage regulator that we talked about in the at the bench shot, and I've wrapped them in electrical tape multiple times and taped them together. Again, this is mains voltage. You cannot be safe enough with this. So the next step, as we talked about before, is to do the mechanical joint with the wires for the table, for the power, solder it, heat shrink it, and then electrical tape it. Again, you cannot be overly safe with mains voltage. So with this one, all you basically want to do is match color to color. Right, green is our common ground. There's nothing metal in this table, If you're doing this with a metal table, I would recommend that you attach the common ground to the metal of the table. That way, if for whatever reason the table ever becomes energized, the common ground will keep you safe. So now that we have the mechanical joint done, I'm going to grab my soldering iron and I'm going to tell it to heat up. And if you're going to be soldering, you obviously need some solder. So the soldering iron is now up to temperature. First thing you want to do whenever you're using a soldering iron is tin the tip. It just helps with the thermal transfer. Try not to inhale the vapor. I don't have a fume hood here obviously, but we'll deal with it. So I'm just going to go in, and this is really high gauge wire. So I am going to use a little bit of a contact with the soldering iron first, just to try and get all of these wires to heat up. And then you can see that it now flows from the other side. And that will ensure that these connections just never come apart. Add a little bit of solder to the soldering iron to allow for thermal transfer, and then the grounds. Okay, so now that we've got those soldered, the next step that I had mentioned previously is that we're going to heat shrink these. Again, just to give them another level of insulation so that we don't get any arcs, we don't get any heating, we don't have any issues from inside of this cardboard mostly table, which would probably turn this into a huge fire hazard if we weren't safe with this. So please, don't use just electrical tape. At the very least, use Marrettes and electrical tape. Solder is always good, heat shrink tubing is always good. So we're going to grab our heat gun. So I apologize for the audio in advance because it's probably going to get turned to crap pretty quickly. We have a couple lengths of heat shrink tubing. And if you've never worked with heat shrink tubing before, this is just a polymer basically that looks like a straw. But when heat is applied to it, it shrinks to half of its size. This is great for insulating electrical connections, for almost anything you could use it for. So we're going to go ahead. The first one we're going to do is I'm just going to isolate the black wires. Slide the heat shrink tubing, if the wires want to cooperate with me, over the connection to try and get the actual exposed metal towards the middle of it. And then we're just going to hit the heat gun. And the ground line. And that should provide us an excellent first line of insulation on this connection. As I said, when we tip this table up and we start to do this more, I am going to put electrical tape around this as well. So as I talked about at the bench, just a quick recap. We have the standard monitor plug to power our monitor. We have the red JST connector, which is putting out 5.2 volts at 5 amp. And we have the black JST connector, which is putting out 12 volts at 5 amp. For most of our stuff, it's going to be the 5 volts that we're going to be using for the USB. This 12 volt lead is only for a lighting solution that's going to be built into this specific table, but is not necessary for yours. So the next step and the next component that needs to be attached to this on our journey to get this working is our modified USB hub. Okay, as I said, I pulled off the barrel jack connector and I attached a JST lead to it. This will allow us to feed 5 volts from our power system directly into the USB hub. This USB hub will then be used to power the majority of this table. So we're going to go ahead and we're just going to connect it. JST connections only go in one way, so you don't have to observe for polarity, but because I'm crazy, I like to anyway, and notice black to black and red to red. Okay, so at this point, the next thing that needs to be plugged into our little system here that will be embedded into the table is our HDMI to VGA adapter. Now, I know that there's a bunch out there that don't require the external power, that can use just the power from the HDMI. I apparently did not get one of those. So what we're going to do is we're going to remove the USB cable and we're going to put the adapter aside for a second until we're ready to install the actual controller. However, the USB cable that needs to power it, we're going to go right ahead and plug that into the USB hub. The next component is an optional one, and we talked about this when we were at the bench. It's a hard drive to hold the ROMs for the table. There are numerous ways that you could do this. The hard drive is probably the most common way. However, you could grab a 128 gig USB stick. You could grab a 128 gig SD card. I chose this because I can get 200, 300, 500 gigs, a terabyte worth of ROMs into this table, and I just happen to have the adapter and the hard drive in the lab. So as I said, there are two ends on this. The first end on the cable is one for data and power. The other end is for power alone. For this particular one, we want that end to go into the hub to grab power. The other end will go to whatever controller we're using, whether it's the Raspberry Pi or whether it's an IMX6 board. So we've put the table upright, so we can look at actually installing these pieces into the table itself. As I talked about before, I don't know if we can get it on camera, but there is a bit of strain relief on the inside of the table. And there's a zip tie on the bottom of the table as well that nobody's going to be able to see right now. Purpose for those is if somebody trips, I don't want to yank on power cords. Okay, so what we're going to do, and what my design is at this point, is to take our power supply brick first and just slide it into the corner here. We're going to actually remove, or at least flatten, some more of this cardboard stuff in the table to give me a little bit more room. And we're going to tuck that up and in there like that. This is the monitor's power cable, so we're just going to leave that hanging where the monitor will go once we're ready to put that in. From here, we have our connected USB hub, which we will tuck into the side here. Once again. Okay. And then we're going to take our hard drive. And our hard drive is actually going to live right over here. Now when we go to permanently mount this and we're done, we're actually going to double-sided tape or Velcro it down to this area here. So we have our connection for the hard drive. We'll plug it in temporarily. And leave that sitting there loose for now. And now we have all of the power connections that we need. The other thing I'm going to insert temporarily is this HDMI to VGA adapter. I'm going to plug into its power feed. Okay, so now at this point, we've completed the common electronics and common components part of this table. Stay tuned for the next video where we talk specifically about the Raspberry Pi, getting its image downloaded, getting the SD card set up, installing the Raspberry Pi into this table, and getting everything up and going. I'd love you to take a moment to like, share, and subscribe down below. I hope you learned something today, and thank you for joining me in the lab.